Hello. We'll get started in another minute. I think you can hear me, right?
Yes, sir.
Hello. Yeah. So
Yes,
we'll
sir.
wait. Yeah, sure. We'll wait for one more minute. And just mute yourself. Once you have any questions or something, you can unmute and ask me.
Hello.
Yeah. Hello.
Yesterday, sir, I was disconnected for last 20 minutes, I think, 20 to 25 minutes.
So what's your ID? What's your name? I'll send you.
Shiva. Shiva.
Sure. Right. Just a second.
Yeah.
I'll send you the video recordings or something. Okay. Don't worry about it.
Okay, sir.
Yeah. Yeah.
I'm in between disconnecting, sir. That is my issue, or I don't know what happened. 5 minutes or something.
No. Maybe your net issue kind of thing because we had the class for the complete 1 hour 50 minutes or something yesterday.
Okay.
So maybe it's an issue from the net issue or something from your end, basically.
Okay, sir.
Yeah, sure. Okay, so we'll get started. In the last class, like what we are discussing is we are discussing something about the architecture of DB2. So I'll just open it again. I think you people have already the links from where you can see the architecture of DB2. Okay. So yesterday, I mean, we have discussed a few things like we are seeing like what is a process. Just to quick recap the things what we discussed yesterday. Basically, let me open the notepad which we opened yesterday. Basically, okay. I think I opened a different right. Okay, that's fine. Okay. So what we have seen yesterday is like we are seeing like what is a process. So in short terms, a process is nothing but say program which is a process is nothing but say anything which is running is called I mean any program which is running we call it as a process. Okay. Yesterday we have seen small examples like when you open a notepad at the backend, like what are the process which starts, and if you do the operations, what exactly the process is doing. Okay. On the same lines, you can see here anything which you see in this diagram, anything which you see in a circle is a process which is running at the backend basically. Okay. And we have seen like what processes are running at the backend in Windows. Okay, so in future we'll also see like what are the processes which are running on Linux when DB2 is running. We'll see those kind of stuff basically. Okay. So we are seeing something about the process. As I told you, this is a client and this is a server, and the client always tries to connect to the server using some protocol. So these are the existing protocols which are there for DB2 basically, and a lot of people, as I told yesterday, they use TCP/IP protocol for connecting from your client to server basically. Okay. And for every new connection in DB2, a process starts, which we have discussed yesterday, is called a coordinating agent. So as we have discussed yesterday, coordinating agent acts as a mediator in between your client and the server, basically. Okay. So if a client connection comes on the server side, a coordinating agent starts. If we have 10 client connections, 10 agents will be running on the server. If we have 1,000 connections, 1,000 agents will be running on the server basically. So for each and every client connection, an agent runs on the server basically. Okay. So this is what we have seen yesterday. And let's say this client is running a query called select star from employee. And we have seen that when the agent starts, the agents will speak with another process which is called prefetcher. Okay. So what is the job of prefetcher? The job of prefetcher is to fetch the data. Okay. So as I told you yesterday, like all the data will be stored on the hard disk basically. Okay. So the prefetcher, it fetches the data from your hard disks and it puts the data to your buffer pools. So if you're wondering what is the buffer pool which you have seen yesterday, buffer pool is nothing but it's a part of your RAM where DB2 will bring the data basically. Okay. So we'll see like how to create buffer pools and what are the different sizes in which we can create buffer pools in future. But for now, simply remember that buffer pool is nothing but say part of your RAM where DB2 is going to bring the data. Okay. So I'll give you some simple examples. What is the buffer pool and other things. Okay. So let's open some MS Paint or something. So let's say, I think most of the people here, they know what is a RAM and other things, right? Let's say I have a basically, let's say this is a RAM, my system RAM, and let's assume that my system is having somewhere near to 16 GB of RAM. In companies, you will be having a huge amount of RAM. So let's assume that my system is having 16 GB of RAM. And out of this 16 GB of RAM which is present, let's say there are two applications which are running on my server. Okay, let's say that SAP is running on the server and DB2 is also running. Okay, so SAP software will, okay, on the same lines the DB2 software will also store the data on the disk. Okay, when SAP people are running, the data has to be copied to the memory, and when DB2 people are using, they have to copy to the memory. Okay, so what exactly most of the softwares do, they try to allocate some memory in the RAM before starting the operations or before doing any operations. Okay, on the same way, DB2 software also tries to allocate some memory in the RAM basically. Okay, so out of 16 GB, how much memory can be allocated to DB2 and how much memory can be allocated to SAP? There are a few lot of configuration ways in which you can do basically. Okay, for now, for simplicity, let's assume that, okay, 10 GB was given to DB2. This is just an assumption. Okay, so let's say 10 GB was given to DB2, and let's assume that 5 GB has been given to SAP and 1 GB has been taken care by operating system to load the data kind of thing basically. Okay, so DB2 can at any moment of time use 10 GB of data. Okay, out of this 10 GB, I can create a buffer. So this is something which we call it as BP. BP stands for buffer pool. Let's say I have created a buffer pool which is of 8 GB. So what is buffer pool? A buffer pool is nothing but it's a part of your RAM where DB2 can bring the data. So if your data is present on the hard disk, basically all your data will be stored on the disk. As you know, the data has to be copied from your disk to some part in the memory. So what is a part of your memory where DB2 is going to bring the data? We call it as a buffer pool. Okay, so is it clear what is a buffer pool? Your DB2 memory can be huge, out of which your DB2 memory can have a lot of internal things basically, out of which buffer pool is the main component. Your DB2 allocated memory can have a lot of components, out of which buffer pool is the main component basically. So buffer pool is a place where DB2 used to bring the data from your hard disk to memory basically. Okay, is it clear till this point what is buffer pool? It's a part of your simply memory kind of thing basically. Okay, if you want to make a note of this, you can just make a note of this quickly. I mean, this is just as an example kind of thing. Does not really make any sense. Okay, but in case if you want to note it down. So this is your memory. I'll keep on telling like how many memory components will be there in DB2. So for now we are discussing about buffer pool, but in future you will see there are more than 20 to 30 buffers which will be created in this RAM part of thing, like the buffers or the lock buffers. So I'll tell you in future like how many components will be created in the RAM for DB2 basically. Okay. So just make a quick note of it in case if you want to. Okay. So any data which is present in your disk, which is present on the hard disk, has to be copied to your memory basically. So it will be done from your disk to memory basically. Clear? Okay. Make a quick note of it. Remove this and I'll start with the rest of the process which runs at the backend. Okay. So we'll get started with the new thing. Okay, so moving to the next thing. So this part is coordinating agent is clear. Now prefetcher is clear. Okay, now we have one more question which you need to understand. Let's say, as I told you yesterday, I have a table which is having 10 lakh records. As I told you, the data will be stored on the disk, and what I'm saying is the data will be copied from your disk to memory. Okay, so let's take another example to find out like how the operation happens at the backend, not only in DB2, in a lot of softwares which happens. Okay, so I'll take you one more example. Let's draw some diagram quickly. Okay, I don't know, here there should be something called it is mistake. Okay, they don't have cylinders kind of thing. Okay, that's fine. Okay, so let's say the same example kind of thing. Let's say this is my RAM. For simplicity, this is my RAM, and all my data is stored in the disk. So let me draw. Let's say these are the disks which are present in the disk basically. Okay, let's say I have a table which is employee, which is stored on my disk. Okay, so let's say my employee is of 10 GB. So the data which is stored for my employee table is of 10 GB, and let's say my RAM is of something near to 4 GB only basically. Okay, this server is having very less amount of configuration, out of which let's say 1 GB has been taken by OS. So what is the remaining thing which is present for DB2? Let's say DB2 software is only running on this server. So the complete rest of the memory, which is 3 GB, can be used by DB2 basically. Okay. Now the same consideration, let's say the client is running a query, which is a simple query basically. So let's say the client is running a query called select star from employee. Here you can see that when the client is running such query basically, or I'll remove this. Okay, so when the client is running a query called select star from employee, here you can see that the employee table, which is how much data is present with the employee table, the 10 GB of memory is present with the employee table. Okay, and when the client is running a query called select star from table name, the complete employee data has to be processed. So in this case, you can see what is my table size. My table size is somewhere near to 10 GB basically. Okay, so this 10 GB has to be copied to your memory. Okay, so if you look at this realistic example, your RAM is only 3 GB. Okay, so what I'm trying to say is in this example is when I say the prefetcher is trying to copy the data from your disk to memory. So in this example, you can see when the client is running a query called select star from employee, it has to copy the 10 GB of memory and it has to scan the 10 GB of memory. Okay, so let's say DB2 prefetcher is trying to pull the data. So when it is trying to pull the data, it cannot pull all the 10 GB of memory from the disk and put it up to the memory. It can only process 3 GB. So what really happens is DB2 will try to copy the first 3 GB, it processes in the memory, removes the 3 GB, copies the next 3 GB, process it, removes the data, copies the next 3 GB, process it, removes it. The last is 1 GB, it copies the data to the memory, process it, and once all the data has been processed, then only it will return the results to the end clients basically. Okay, so if you look at the simple examples, the DB2 has to copy the data from here to here, and the processing has to be done in the memory. Once the processing has been done, this data will be removed out. It will be written to some temp space. I'll tell you this. The next 3 GB will be copied. Processing will be done. The data will be removed. The next 3 GB will be copied. Processing will be done. So 3 GB plus 3 GB plus 3 GB, which is 9 GB. The next last 1 GB will be copied to your memory. Processing will be done. So at any time, if your query is running, the data has to be copied. So it depends upon your size of the memory. Okay, if your memory is very huge, then it can copy all the 10 GB in a single shot. If the memory is not so huge, it copies it part by part basically. Okay, so this is not something which is specific to DB2. This is done at OS level. So if you're running something, it's the same thing. Like let's assume that you're playing a game. When you're playing a game, the levels has to be loaded. So the level, when it is trying to copy the level, it takes some time. That's why you see something called loading kind of thing. But once the complete data has been copied to your memory, you can play the game. Okay. So let's say my level 1 of the game is completed, and you want to go to level 2, then you will see sometime like loading will come. So what really happens in between this time is the level 1 software which is already copied to your memory will be removed from your memory, and the level 2 game which is present on your disk will be copied to your memory. So there is some time which it needs for removing the data from the RAM and copying the level 2 data to the memory. So this time we call it as a loading, or this is the time in which the the software will do the operations at the back end basically. Okay. So is it for all the people what I'm trying to explain here? Like how the data will be copied, how the processing will be copied, how the data will be removed, and all those things. Is it clear, or shall I explain you one more time? Yes, no? Clear for the people? Hello? Anyone there? Hello? Is it clear? Yes, sir, it's
Yeah,
clear, right?
yes.
Okay. Yeah, okay. So I'll give you one more example so where you can understand this. So we'll go slow, so don't worry about it. We can have more number of classes. Okay, I just want to be clear. Okay. So I'll give you the same example again, but this is important from the perspective, from the what you say the performance point of view. So try to understand this very clearly. Okay. So the same example, let's say we have a RAM and we have some. Let's put only one disk for simplicity. Let's say I have my disk where my data is there basically. Let's say my employee table is there. The same thing what I'm seeing, which is having 10 GB. And as I told you before also, my RAM is of 4 GB, somewhere near to. This is 4 GB. Sorry. Let's say out of 4 GB, 1 GB is being taken by OS. So I'm left with only 3 GB. So DB2 can use 3 GB of memory. Okay. Let's say the same example what I have given you before. Let's say the client is running the query. So the query which the client is running, as I told you before, is select star from employee. So as I told you before, the data has to be copied from here. So what is the process which runs at the back end which will help me? Prefectures are the process. So what are prefectures? They are nothing but they are the process which runs at the back end. So this process will be reading the data. So from where they will be reading the data? They will be reading the data from the disk, and they'll try to copy the data to the memory. Okay. But the question is, how much data can be copied to your memory at a single shot? So can it copy the 3 GB in a single time, or will it do it part by part? Okay, so any answers for that basically? So if I say select star from employee, I have to copy 10 GB of data to the memory. I cannot copy the 10 GB in a single shot. I can copy only 3 GB of memory because my RAM is limited to 3 GB, which was allocated to DB2. Okay, so the question is, will DB2 copy the 3 GB in a single time, or will it do part by part? Can anyone guess what is the answer basically? Will you do part by part operations of 3 GB, or will it copy the 3 GB in a single operation basically? You can put it in the chat if you want to answer. Any suggestions? I think it's part by part. Yes. Okay. So what is the part there, and what is the size of the part basically? So remember, at OS level, we have something which you should be very clear. We have something which we call it. A lot of people they call it. We have something which is called as page size. Okay. So what is page size? A page size is nothing but it is the smallest chunk which is used for copying the data from your disk to memory or from memory to disk basically. Okay. So if you do a query called select star from employee, your 3 GB in this example cannot copy from your disk to memory in a single operations. It does by part by part. So what is the smallest part, or what is the part, or can I specify the size of the part? So we have a lot of questions there basically. So remember, there is something which we call it as page size. So what is the page size? A page size is nothing but it is the smallest chunk or the smallest block which is used for copying the data from your disk to memory basically. Okay, and there are some standard page sizes which are defined not only in DB2, it is defined at OS level. Okay, so the page sizes are 4K, 8K, 16K, and 32K. Okay. So just make some notes, draw this diagram if you want to. I have the material, I'll share you the material. So there is something called page size. So what is the page size? It is nothing but the smallest block used to So what are the standard page sizes? We have something called 4K, we have something called 8K, we have something called 16K, and we have something called 32K. Okay, I think most of the people, you know, like what is K, right? K stands for kilobyte. If you say 4K, which means that 4 into 1 kilobyte is equal to 1024 bytes. So which is equivalent to somewhere near to 4096 bytes. So this is very much important, so try to understand this. 8K stands for 8 into 1024 on the same lines. If you do a simple math, it will be somewhere near to 8192 bytes. Okay, so do the simple math. So at any time, if your data has to be copied from your disk to memory, it has to be done through pages, or we call it as page size, and there are 4 standard page sizes, which are 4K, 8K, 16K, and 32K, which means that, see, the data will be copied from your disk to memory using one of the page size. Let's say if you don't specify anything, or if you don't specify anything, DB2 will follow the default page size, and the default page size is 4K basically. If you don't specify anything, or if you don't configure anything, so the default page size is 4K, which means that DB2 will copy the data from your disk to memory in 4K. So first it will copy the first 4K, then it will copy the next 4K, then it will copy the next 4K, then it will copy the next 4K. So it does copy page by page basically. Okay, so that is what happens at the back end basically. Okay, so just make a quick note of this stuff, and I'll let me know once you're done. Do it quickly. Done. Okay, so the question is, can I specify the page size? If you don't specify any page size, DB2 will use the default page size, as I told you before. Okay, or in contrast to that, can I specify the page size? Yes, you can specify the page size. Okay, simple question. Which page size? Let's say I have to copy 3 GB of data from your disk to memory. So I can do it through 4K, I can copy it through 4K, and I can copy it through 8K, I can copy it through 16K, and I can copy it through 32K. So you can use the copy, you can specify any page size basically. Okay, so if you specify 4K, it copies in one iteration, it copies 4K of data. If you specify 32K, it copies 32K of data. So you can think logically that if you use 32K, your data will be copied much more faster from your disk to memory basically. Okay, so you can specify the page size. Okay, but the question is, where do I need to specify the page size? Okay, so remember, you can configure the page size at two places, basically two ways basically. One is while creating the database. So when you're trying to create the database, you can specify what is your page size. If you don't specify anything, it follows the default page size, which is 4K, which we have discussed already basically. Okay, or the second is table space. Table space we'll see in future what is a table space and other things. So let's keep it for now basically. So the two important things is, can I specify the page size? This is important because if you, I mean, you'll understand this in the clearer in the later part of the course. But for now, just remember that page size is the smallest chunk which is used for copying the data. You can specify the page size. If you don't specify anything, it follows default page size, which is 4K. If you want to specify the page size, where you have to specify when you're trying to create a database, okay, or when you're creating a table space. I'll tell you what is a table space in the next classes, but in the last sessions, you know how to create a database. Okay, so the simple example to create a database which we have seen is DB2 create DB your DB name. This is a simple example which I have shown you how to create a database in DB2, and I told you like a database is nothing but collection of objects. You can create tables in database, you can create views, you can create indexes, you can create table spaces, buffer pools, procedures. A lot of objects can be created in a database. Okay, and I also told you that this create DB option, create database, has a lot of options after it. Basically, there are more than 250 options. You need not understand each and every option. Okay, so if you create the database with this thing, it follows the default page size, which is 4K. Okay, or if you want to create a database with higher page size, let's say I want to create a database with 8K, or I want to create a database with 16K or 32K, what is the syntax for that? So the syntax for that is the same create DB syntax with one new option. So you have to specify the complete value of 8K. So when I say 8K, 8 into 1024, which is 8190 bytes. So here I am specifying it. Okay. So this is the option which you have to specify with the create database command. So if you specify this option, DB2 will create the database with 8K as a page size. So when you try to run any query, it uses the blocks as a 8K. It copies the data as 8K instead of 4K basically. Okay. Or the same thing, if you want to use the page size as 32K, okay. The same example, if you want to use 32K, let me do a simple math. So 32 into 1024, which is 32768. So you have to specify value here, which is on 32768. So if you want to create a database with 32K page size, this is the command. If you want to create with 18K, this is the command. If you specify normal database command, this will create with default page size, which is 4K basically. Okay. Clear? Just make a note of it. In between, I'll do one thing. I'll just run the command, and you can make a note of these things. Okay. By the time the command will run, basically, so that you can save some time. Okay. So let me quickly run the command. So I'll tell you what DB2 start is and what DB2 SAPT is. Okay. Just give me 1 second. Okay. So I told you a few initial commands in the previous classes. If you want to see how many databases are there, I already told you the command is list DB directory. If you want to create any database also, I told you the command is create DB, your database name, let's say sample. If you want to create, this is a simple syntax which we have done. The sample is already created. Okay. Let's say I want to create a different page size. I want to specify the page size as a different thing, so I'm running the command. Okay, so you can see here I'm creating a database and I'm specifying that this database should use 8K as a page size. So this is the syntax for it. Just make a quick note of it. Just make a note of it basically. It's in between, my database might be created. Okay, so make a quick note of the things. Okay, let it run. Okay, so let's see my database is created or not. So this is still running. So simple thing, when you're creating a database, you can specify the option. If you don't specify the option, it goes with the default page size. If you specify it, it follows the new thing basically. That is as simple as that basically. Okay. Okay, so we'll start it again. I'll show you the diagram again. Okay. So in this diagram, we have seen like what is buffer pool, what is disk and other things. Okay. Now we'll see what is page cleaners. Basically, you can see here there is something which is called as page cleaners. Okay. As the name says, or before understanding what you say the prefetchers, let's say different clients are running the queries, and the agent started, the prefetcher started, and the data has been copied from here to buffer pool in terms of page size, here to here, here to here. But let's say at one point the prefetcher has copied the data. Let's say my RAM in my buffer pool is of 3 GB only, and this has copied 1 GB, and this has copied 1 GB, and this has copied 1 GB. So we can see that clearly in this example, my complete buffer pool or RAM has got filled up with data. Okay, and another client came, so he's still trying to read some other data. So an agent has started. The agent is speaking with prefetchers to still fetch the data. So it is trying to fetch the data, but remember here we don't have any space in the buffer pool. Okay, so if you don't have any space in the buffer pool, so DB2 cannot still copy the data from your disk to memory basically. Okay, so what will happen in these scenarios? Okay, so the prefetcher's job is only to fetch the data from your disk to memory basically. Okay, in this scenario we need to do some cleanup. Okay, so we need to do some cleanup in the buffer pool, or we need to do some cleanup in the memory basically. So which process does that? You can see there is a process which is here, which we call it as page cleaners. As the name suggests, a page cleaners will clean up the pages which are present in the buffer pool basically. Okay, so just make a quick note of it. So there is a new process which we are going to see here, are page cleaners. So what are page cleaners? Page cleaners are nothing but they are the process which cleans the buffer pools. So as the name says, page cleaners means they are cleaning the pages. From where they are cleaning the pages? They are cleaning the pages from the buffer pool. Which pages it will clean? It will remove the pages which are unwanted basically. So just make a quick note of it. We'll see how it happens and what algorithm it follows at the back end. So we'll see here like okay. So as I told you, the in this example basically when my buffer pool is got completely filled up, the page cleaners will be cleaning the pages. Okay, so you might have read in your college days or somewhere there are a lot of page replacement algorithms. If you remember in mostly in your engineering days or master's day places, there are a lot of algorithms which we call it as page replacement algorithms basically. So if you remember, there are some standard algorithms like FIFO, which stands for first in first out. There is something called LIFO, which is nothing but last in first out. So these used to be 40 mark questions or 20 mark questions in your graduate terms or something basically. Okay, but these are very important algorithms. So see, if you are wondering what these are the algorithms which the databases follows. Even Oracle and DB2, it follows LRU algorithm, which is nothing but least recently used algorithm basically. Okay, but remember there are some standard algorithms which are present. For the first, which as I mentioned here, is FIFO, which means that the first in first out, the page which meant to buffer pool first will be removed. Okay, so let's take a simple example, but let's try to understand these acronyms. FIFO stands for first in first out. The page which went to buffer pool first is the candidate to be removed. Okay, LIFO stands for last in first out. The page which recently went or the lately went will be the candidate for removing. Okay, the last is LRU, which stands for least recently used. Let's say 100 pages were copied to the buffer pool, out of which one page is getting leastly used basically. If you are not using any page in the buffer pool, then the page is a candidate page for removing it basically. Okay, so I'll give an example. If you're not understanding this, let's take a small example to understand this better. Okay, let's say this is the same example what we are seeing. Okay, so let's say the client is running query called select star from employee. So here let's assume that some pages are getting copied. So Here, let's say it has the data which is stored in pages. So let's, for simplicity, this is page 1, this is page 2, and this is page 3, or we'll see. I'm just showing an example 4 and 5. Let's say my disk has 5 pages, and when the client is running a query called select star from employee, the first page will be copied to your buffer pool. So the page 1 will be here basically. Then the second page is getting copied, so the page 2 will be copied here. Then the third page is getting copied, the page 3 will be here. For simplicity, let's assume that my buffer pool can only accommodate 3 pages. I mean, that's not an ideal solution, but for here, let's assume that. So my 3 pages got filled up in my buffer pool, and I want to copy another page which is page 4, but I don't have space in my buffer pool. So I should remove some of the page which is already existing there basically. Okay. So which page I have to remove? Should I remove the page 1 or page 2 or page 3? So it depends upon the page replacement algorithm which we are seeing basically. So the first page replacement algorithm is called FIFO, which stands for first in first out, which means that what is the page which went to buffer pool first. Let's say this page went at 6 o'clock in the morning, this page went at 6:10, and this page went to 6:20. So what is the page which went first? So this is the page which went first. So what the page replacement process does, it removes these pages from the buffer pool and it copies the new page which is 4th. Okay. Again, it need to copy one more page. So what is the first, if it follows for FIFO algorithm, what is the next page which went? So 2 is the next page which went. So it will remove the 2 page. The page cleaner will remove this page and it will try to copy the new page which is 5. So it depends upon the what algorithm you follow. So if you're following first in first out, the first page which went in is the candidate for will removed. If you follow LIFO, which is last in first out, out of 1, 2, 3, 3 was the page which got copied to the memory last time basically. So the last page will be removed basically. Okay. So it depends upon the what algorithm you are following here, but most of the databases like DB2 and Oracle, they follow LIU, which stands for least recently used. So these are the algorithms which are used for doing the cleanup of the buffer pools basically. Okay. So just make a note of it. Any questions till this point? What are these algorithms? What is FIFO? What is page replacement algorithms kind of thing? So these are more than to theoretical things. If you don't understand, also don't worry. Okay. So these are only for better understanding of the architecture basically. So just make a quick note of it. Done? So in between, let me see whether my database is created here or not. So you can see here your database is already created. Okay, so you have created your database with 8K page size, which is nothing but 8K basically. Okay. Clear? Okay. See, everything in this diagram is very important, so try to understand this. You can see 2 arrows right here because the client is speaking with the agent and the agent will return the output to the client. So you can see 2 arrowheads. On the same line, here also you can see that your data will be copied from your hard disk to memory. So you have 1 arrow upwards, and you can see there is one more arrow which is towards the downward, which means that your data has been copied from your buffer pool back to the disk basically. Okay, but the question is when the data will be copied from your buffer pool to disk basically. We keep on saying that the data is read from your disk to memory and the processing is done in the buffer pool, but there are times when your data will be copied back from your buffer pool to disks. Okay, so we'll see when it happens. Okay, I think most of the people you might be knowing a few commands which are nothing but commit and rollback. Okay, so when you say commit, so what is commit in the database world? In the commit is nothing but you are telling that okay, changes should be permanent. So if you're running any SQL query like update query or insert query or delete query, after running the query we say something called commit. What is commit doing? If you're issuing commit point, which means that you are telling that the query should be permanent or the changes should be permanent basically. Okay, if you're saying something called rollback, which means that you're saying that okay, if you're saying something called rollback and changes should not be permanent. So I'm just trying to understand, make you understand like what happens when you issue a commit and what happens when you do a rollback. So look at the diagram. Okay, here we'll see the diagram again. Okay, let's say let's again take a simple example. This client is running a query which is update query. So you know what update query does? Update tries to edit the data. So the same pattern follows. The update will, the coordinating agent will come. This will speak with the prefecture. The prefecture will read the data and it copies the data, and the processing will be done here basically. Okay. So what are with the update query which is running? The updates will be happening in the buffer pool. Remember, buffer pool is nothing but a part of your memory. So all the changes will be happening in the buffer pool only basically. Okay. When the client says commit, so the client after running the update command, he can say either commit or rollback. Okay, if he says commit, which means that all the changes which happen in the buffer pool will be written back to the disk basically. If he says rollback, which means that all the changes which are happening in the buffer pool will be discarded basically. Okay, so there's a simple question: if you want the changes to be permanent, you should run a statement called commit, and if you don't want the changes to be happening, the changes will be discarded. Okay, so most of the RDBMSs, not only DB2, most of the RDBMSs, when you run any SQL query, they copy the data to the buffers, or we call it as a memory basically. They do all the processing in the memory only and they keep it in the memory only. When you issue a commit statement, those changes will be made, written back to the disk basically. And when you say rollback, those changes will be discarded from your memory. It depends upon the end user interaction. So if you say commit, changes will happen. If we say rollback, the changes won't be happen. But internally, what happens? This is the what is the algorithm which it follows. Commit will make all your changes written back to the disk. Okay. So who writes the changes back to the disk? Again, the same process which we are seeing as page cleaners. Okay. So page cleaners, as I told you, will clean up the pages in the buffer pool. So what pages it will remove and what pages it will write back to the disk. The page cleaner's job is to see whether the transaction is committed or not. If the transaction is committed, it will write all the changes back to the disk. That's why you are seeing the double arrow here, the second arrow which is writing to the downwards. If the page cleaner sees the transaction as a rollback thing, it won't write back to the disk. It will simply discard the changes from your buffer pool, basically. Okay, so it purely depends upon what the end client has issued, basically. Okay, so just make a note of these things. Okay, and I'll give you 1 minute. Just make a note of these things, and we'll move forward. So, any questions till this point? Are you getting what we are seeing here? What is commit? What is rollback? What happens at the back end in the architecture when things are happening? Okay. So if you have any questions, you can ask me basically. Clear? Okay. So we'll move ahead. Okay. Any questions before we move forward? Clear? What we are trying to discuss here? I think if people are very silent, then no one asks the questions. Page cleaners does the job? Yes. So page cleaners bring back. Yes. So the page cleaners will write the committed transaction back to the disk. So it's a job of a page cleaner process to write it back. Just to. Yep. Okay. So we'll move forward basically. Okay. So you can see I created a new database in my server. So now you can see 5 databases. If you want to use see it, there should be a new database which is already created. This is the database. And if you want to work with database, I told you the command is simply connect to your database name. In my example, this is the database name. So you are connecting to the database which is created of 8K. So what will be the queries which are running here? The data will be copied using 8K page size basically. Okay. If you try to copy it to the database, or if you try to connect to the database which is created with 32K, all the operations internally will happen in terms of 32K. So it depends upon what page size you specified there basically. Okay, clear? Okay, so we'll move forward basically. We'll see a few things which you should be knowing basically. Okay, I told you previously, like in Windows, if you want to see like what all processes are running at the back end, you can simply go here. You can simply go to the task manager here basically and see what processes are running at the back end. Okay, close some of the stuff basically. So you can see if you in Windows, if you want to see what process is running at the backend, so these are the process which runs at the backend. Out of which you can see there are few DB2 processes also which runs at the backend. So if you want to just see the process which are running at the backend, I think here my client is installed. Okay, so DB2 is not running on my Windows. Okay, so in Linux, I'll tell you some basic commands how to see the things in Linux basically. Okay, so in Linux, if you want to find out like what process are running, we have seen few Linux commands previously. Okay, but now let's see in Linux. If you want to see like what process are running at the backend, so this is a simple command to find how many processes are running at the backend. So I'll run it here. You can see ps-ef. Run this command, which will show you how many processes are running at the backend. The output looks a bit strange. Okay, so don't worry about the output. So you can see there are a lot of processes which are running on Linux. Okay, I'll try to explain you each and everything. Don't worry about it. Okay, so you can see these are the processes which are running in the backend. Okay, out of which you can see that there are some DB2 processes also which are running. You can see these are DB2 processes which are running at the backend. Simple fact: any DB2 process which is running at the backend, the process will be having a keyword called DB2. So you can see here, these are the processes which are having DB2 as a keyword basically. Okay. So how to look at the process in Linux, AX, HP, Solaris, and other thing? The command is ps-ef. Just make a quick note of it basically. So when you do ps-ef, it shows a lot of list. Okay, just scroll down to the top and look for a few things basically here. These are the things which are important, which you should be knowing. I'll explain it very quickly. UID will tell you under which user ID your process is running. You can see here a lot of process they are running. The first column, you can see a lot of process they are running from root. And you can see few process they are running from DB2 SAPT. DB2 SAPT is my user ID, so that's why it is running with DB2 SAPT. Okay. So in this output, the first column is the user ID from which it is running. This is very important, so try to make understand this very clinically. If multiple DB2 things are running, you should know which user ID it is running. But so the first column in the output specifies under which user ID it is running. The second and third are important, which specifies the second column here specifies the parent process ID. Each process, for each and every process, the operating system gives a number which we call it as process ID. You can see here the numbers have been given or if you want to check what are the IDs which are given to DB2, you can see here these are the IDs which are given to DB2. Process IDs are important, okay. And the next column is called PPID, which stands for Parent Process ID, okay. So you can go to Google and do simply like Linux process command. So it will explain each and everything very clearly. But try to understand what I'm trying to explain. UID means user ID, PID means process ID, what is ID for the process, and PPID is nothing but parent process ID. Okay. Each process has a parent. Okay, each process has a parent. Let's say, I'll give you a simple example again so that you can understand this clearly. Let's say I'm giving a simple example. Let's say DB2, when you start DB2, one process starts which is called DB2 SYSC. I'll show you this process. DB2 SYSC starts another process. Let's say it is starting DB2 BP. And this process can start another process. So one process can start another process, another process can start another process. Okay. So as I keep on telling you, let's say this process, let's say the ID which was given by operating system is 123, and this process is a parent process. So what is the ID for this process? Let's say the parent ID is 151. So which means that this is the ID for this process, and this process has a parent, and the ID for this process is 151, which means that this process is having an ID of 151. And all the process will be under root, as I told you in the root. So root will be having a process ID of 1. In Linux, as I told you, root is a super user, or root is a thing. Okay, so the root has a process ID of 1. So all the other process will be inherited from the root ID basically. Okay, so if you're wondering why should I know what is process ID and what is parent process ID, this is important in some circumstances where I will tell you. Okay, so simple thing. Process ID means ID of the process. Parent ID means from where it got inherited. You can see here the first process which gets started is from the root, which is of process ID 1. Okay. To kill any process, you can simply either kill this process or you can kill this process basically. Okay. I'll clean it up and write it again so that it will be clear for you. Okay. Let's say I have a process named DB2 SYSC. So try to understand these names. These names you'll be seeing in future. So it invokes another process which is called DB2 BP. Let's assume that this process ID is 153, just as an example, and this process ID is 123. So if you just do ps-f, this process has a process ID 120, this parent is 153, and this has a parent. So the first parent of all the things is the process ID which starts with 1. Okay, so it follows a tree structure basically. Okay, so the question is, can I kill this process? Yes, if you want to kill this process, you should know the ID which is 123. Or can I kill this process? Yes, you should know the ID for 123. Okay, so in Windows also you can see there is the similar thing is explained in Windows also, which I'll show you. I'll clean up some of the stuff. So in Windows also, let's show me a simple example. Okay, so let's say this is a process. If you right click here, there are two things which you can see here basically. Okay, one is end process. The end process will kill the current process only, and you can see there is one more option which is called end process tree. The tree will kill all the VMware processes which get started basically. Okay, so two things you can do: killing the process which you want to, or killing the complete tree basically. Okay, so if you want to kill the complete tree, all the process which are running for that will be killed off basically. Okay, or if you want to kill some specific thing, so this is what I'm saying as parent process ID. So it happens with all the operating system. It's just the way you have to look into it basically. If your system is hung or something, most of the people they go with process and the process tree. If some particular one process is hanging, they'll simply go to end process kind of thing. Okay, so you can choose among yourself which process you have to kill basically. Okay, the reason why I'm trying to tell these names is, remember, a lot of people ask a question like, can I check whether my DB2 is running or not, or whether the DB2 is running or not? So you should look for this process. This is a very important process in DB2 which you should know all the time basically. Okay, So just make a note of it, saying that DB2 sys process should be up and running for your DB2 DB function. If you see this process, which means that your DB2 is up and running. If you don't see this process, which means that your DB2 is crashed or someone has stopped the DB2 basically. Okay, and DB2 still stands for system controller. Okay, so system controller process, or some people they call it as the DB2 system controller process. So question is how to check whether my DB2 is up and running. So look for this process. If this process is running, which means that your DB2 is running. If you are not able to see this process, which means that your DB2 is not running at all. Okay, so just make a quick note of it and write it. Clear? So if you want to see, as I told you in Linux, how to look at the process ps-ef, just do enter. You can see a lot of process. So what is the process which I'm saying? This is the process which I'm interested in. If this is running, it means your DB2 is running. If this is not running, means your DB2 is not running. You can see under which user ID this is running. For my system, it is running under DB2 ID. What is the process ID? My process ID is 18837. What is the parent process ID? The parent process is 18835. Basically, okay. So this is a way in which you look into the Linux, how to look at the process and everything. I'll do one more thing. I'll stop DB2, and you can see that this process is not running. I know how to stop it. You might not be knowing it at this point of time, but in future, I'll tell you how to start DB2 and stop DB2. So there are commands for that. So DB2 stop is a command to stop the DB2. So I'm just running it. In future, I'll tell you how to create instance and how to start and stop it. Okay. For now, just see that I stopped DB2. Now, if we'll check whether we are able to see DB2 sys process. So are you able to see the DB2 SYSC process here? Just I'll scroll to the top. You can see that nowhere any DB2 process is running, which means that DB2 is not at all running on this server basically. Okay. So if someone asks you a question in the interview or in the real time, if you want to check whether your DB2 instance is running or whether DB2 is running, look for this process. This is a simple mechanism to find out. Okay. If you are able to see this process in this output, which means your DB2 is running. If not, your DB2 is stopped or DB2 is not running kind of thing. Okay. Let me start it again and let me show you the output again. So the way to start it is DB2 start. So I started it again. Now, if you want to just cross check it again, you can see that this process started again, and you can see this is the you can see what is my process ID and what is my parent process ID kind of thing. Okay. Clear? How to check whether your DB2 is running or not in the Linux server or AX server or HP server or any Solaris server, any server. In Windows also, if you want to find out whether your DB2 is running also, you should also look for the same process, which is DB2 SYSC. So the process name is same across Windows, Linux, AX, HP, Solaris, and all the OS basically. Clear? Okay. Okay, so the next thing is we will see some of the Linux important things. In the before class, I told you a few basic commands like how to what is ls command does and what is user add and how to create a user and how to switch to the user kind of things. Okay. Today we'll see like what is Linux. I think most of the people, some people who know it, just try to. Okay, crap. Just give me 1 minute. See, I tried to upload the software yesterday, but I think it failed in between. Today I'll definitely upload the software and give you the links. Just give me one more day. So this is an important link where you can understand the what is the where is the chart. So just bookmark these links. You can understand it. So just try to open that link and see what are file systems. Before that, I'll explain you what are file systems. Okay, just save that and you can read it maybe after the end of this session, basically, or tomorrow, by tomorrow, before the next class. Okay. So let me tell you something before we getting started with the file systems, basically. Okay. See, I think you people are comfortable with the Windows, right? Basically. So let's take the same example of Windows. Let's say you have purchased a new laptop from the market. I think nowadays a lot of laptops are coming with the pre-configured and pre-OS installed. Like if you purchase a laptop nowadays, you will get Windows 10 pre-installed there on the laptops. Okay, but still you can go to the market and you can purchase some assembled workstations. Basically, you can tell what is the RAM size. You can customize it. Basically, you can select how much RAM should be there and how many processors should be there and what should be your hard disk size. You can assemble everything and they will give you the workstation with all the assembled parts of your choice, basically. Okay. But the question is, once you got the assembled part, the first thing which you do, let's say you got a workstation which is of 1 terabyte, basically. Okay. Okay. What people used to do, basically, they used to first do the partition of the disks. Okay. So if you have a hard disk of 1 terabyte, how many partitions do you wish to have? It depends upon individual choice. Some people, they split the 1 terabyte of disk into 4 partitions of 250 GB each. Some people, they put it as 10 drives of 10 GB each. It depends upon, or 100 GB each. It depends upon their individual choices, basically. When you got a new brand disk, and if you're trying to install Windows on the top of it, you cannot directly install it. The first thing which you need to do is to have the disk partition. You should have the drives. Okay, so you should install some file systems on the top of it. In Windows, normally people go with FAT32 or they go with NTFS file systems, which is the default. You need not do anything. You just put the Windows CD. The first thing which it will ask you, do you want to partition it? If you say yes, it will ask you how much should be the disks or the partition size. If you keep on answering, it will ask you what is the file system. If you say it as FAT32 or NTFS, it does all the work for you, basically. Okay. But the question is, your newly branded hard disk has to be partitioned all the operating system, which is either Windows operating systems. Okay. So typically in Windows, what people do, people will create the drives like C drive, D drive, E drive. It depends upon your choices. Basically, naming convention you can follow. Okay. On the same way, let's say I have brought a new workstation from the market and I want to install Linux now, not the Windows. Okay. So if I want to install the Linux, what should be the disk layout or what should be the partitions which I have to make? So in the Linux, you have to create a different partitions, which we'll see now basically, and with the link has the link has the details basically. I'll try to explain it in a very high level. Just try to, in Linux, remember there is something called slash, which we call it as a root file system basically. So slash is very much important, which we call it as the root file system. Every Linux box, every AX box, every HP box, every Solaris box, they have something called slash, which they call it as a root file system. Okay. Under slash, they have a lot of subdirectories. Like if under slash, they have something called home. So try to understand this very carefully. Under slash, they have a lot of other things. They have something called OPT. I'm just giving an example. Under slash, they have something called binaries bin. Under slash, they have something called temp. So this is the way in which the Linux servers will be laid out. They have something called etc. So there are a lot of other things which I'm not writing here. You simply go to the link which I have given you. Okay, if you simply go to the link which I have shared with you. So this is what he's trying to explain. I have drawn the diagram in the reverse order. He's trying to show it. So this is what we call it as slash. Slash is nothing but it's a root file system. Okay, under slash you'll see a lot of other things, here. So this is important. Just look at here. This is something called slash home. What is slash home? Slash home is nothing but it is the home directories of the user. So any user which you create will be under slash home. And this is the next thing which I'm trying to explain you. OPT. OPT is nothing but it's a place where your softwares will be installed basically. Okay. I'll explain it very clearly here. So remember, in Linux, if you have 1 terabyte of hard disk, the same thing what you have in Windows. So in Linux, you can configure it. You can say that, okay, my slash has 1 terabyte and it will be shared with all the things. Or you can have say that, okay, my home should be 50 GB or my OPT should be 25 GB. So you can specify what should be the size of each and everything basically. Okay. There is importance for each and everything which was created in Linux. I'll tell you. Okay. So this is called home. Let's say I'm creating a user in Linux. How to create a user in Linux? I told you in the previous classes. You have to run a command which is called user add followed by the username. Let's say I'm creating a user on Linux by name Raju. So remember, any user which you create on Linux, it will be created under home. So home is nothing but it's a home directory of the user. You can read this documentation also. So what is home? Home is nothing but the user home directories. Any user which you create, they will be created under home. So I'll give you an example here. So let's say I'm creating a user by name Raju. So where Raju will be created? The Raju will be created under home. So what will be the path? So try to remember these paths. The paths for Raju or the home directory path for Raju will be /home/Raju. These things are important. So just try to understand these things. I'm trying to explain to you again. Slash in Linux, this is the file system which was defined in Linux, AX, HP, Solaris. It is a tree structure architecture. You see everything in tree format. Unlike Windows, in Windows it's very simple. You have drives which are C drives, D drives, E drive, and any number of drives which you want to put it up. In Linux, the layout is a bit different. It's a tree structure. The root of this is called slash, which we call it as a root file system. Under slash, you'll find a lot of things. You need not understand all the things. You just need to understand what is home and what is OPT here. What is home? Home is a place where your users will be created. If you create a user by name Raju, it will be created under which path? It will be created under /home/Raju. These paths are important, so just try to understand this. Let's say I'm creating another user by name Ravi. So where Ravi will be created? Ravi is another user which will be created under home. So this is the user. And what will be the home path? The home path is same. So try to understand these paths. The home path will be /home/Ravi. So these are the paths where Ravi can store the data. This is the path where Raju can store the data. Is it clear till this point? What is home directories, how they are created in Linux? Is it clear? Or any questions basically? I'll run them practically so that you can get some knowledge. But is it clear? So just make a quick note of it. I'll run the commands in Linux server and show you how to create users and other things basically. So the first class you might be a bit new to you, but you will understand these things as the course goes on. So just make a quick note of it. And don't forget to go through the link which I have given you. The link is important. Okay. So just draw this diagram quickly. Okay, let's do some practical thing. Okay, so I'm in Linux box. Okay, so I'm creating a user. I told you in the last class how to create a user add. Let's say I'm creating a user by any name. Let's say I'm creating with use Suresh. So the user is created with name Suresh. Now what will be the home directory? Just look at this example and you can see what will be the home directory of Suresh. The home directory of Suresh will be simple. Anything which you create in Linux, the home directory will be /home/Suresh basically. And Suresh is trying to log in to his home directory. He will see this path all the time basically. Okay, let me show you. Okay. So can I set a password in the? I told you in the last class how to set a password for users. I'm setting a password for Suresh. You can see the password was set for Suresh. Okay. So in future, if Suresh wants to log in, so let me try to log in using Suresh. So what is the user ID? Suresh. And I am trying to log into Suresh. Okay, I think the password is wrong. Let me change the password again. I think I kept some password. Okay. So I log on to the Suresh. If you do pwd, which is nothing but present working directory, you can see that in which home directory he is in /home/Suresh. Okay. So the same thing what I'm trying to tell you, any user which you create on Linux, they will be created under home. So here if you create Raju user, it will be created under /home/Raju. If you create a user in Linux by name Ravi, how to create a user? The command is user add. It will be created under /home/Ravi. And here I have created a user by name Suresh, so it will be created here. Or another example, we'll see it. So just to make the things clearer, let me create another user. How to create a user in this? User add is a command. I'm creating a user by name Anil. I want to set a password for Anil also. I'm setting the password. So the password is also set. Okay, something bad happened. Okay, crap. Let me set the password again. So I have set the password. So if in future, if Anil is trying to log on to this server, what is his home directory? Let me show you. Let me log on first. So he logged on. If you do pwd, which means that present working directory, it is showing as /home/Anil. Okay. So any user ID which you create on Linux, they will be created under /home. And if you log on, it creates under /home/the user ID. This is very much important in Linux, and try to understand this. And simply go through the link which I have forwarded you. It has few of the examples there. I'll show you here. Here you can see the /home. Here you can see a few different examples. /home/student. Student is an user ID. Here it says /home/Linux gym. Just an example. He is trying to create a user by name Linux gym basically. Okay. So any user which you create in Linux, it will be created under /home basically. Okay. So is it clear to this point? Any questions before we move forward? Hello? Okay. So I'll tell you one more thing before we stop it for today. Okay. So the next important thing is, the reason why I'm trying to explain these things is /home is clear, right? There is something else which is called OPT. Remember, when you install DB2 on Linux, the installation will go to OPT. Simple thing. In Windows, if you install any software, where it goes? By default, it goes to C, program files. It creates a directory basically. Okay. So in the Windows, the default location is C drive. Inside the C drive, you can find a directory by name program files. Inside program files, you can see the subdirectories for the software which you created basically. Okay. As we are learning DB2 on Linux now, I'm just trying to tell you, if you install DB2 on Linux server or AX server or HP or any operating system of your choice which are of Linux flavor, remember the softwares will be installed in OPT. We call it a /OPT. So it creates a set of directories there. I'll give you the directories location. Just try to understand this location. Under OPT, DB2 creates another directory. So this is the path which it follows. Inside this, it creates a directory by name IBM. So this is the standard which IBM people will follow. And inside IBM, it creates another directory by name DB2. And inside here, it creates another directory by name version 9.7 if you're trying to install 9.7, or if you want installing 10.5, it creates another directory. Okay. So this is the complete path where DB2 software will be installed, and this is mandatory for all the companies. So if you want to find the complete path where this software is installed, we call it as /opt till this point, because we are under /opt. The next is IBM, the next is DB2, next is V9.7. So if someone asks you what is the default location where your DB2 will be installed on Linux, remember the complete path is /opt /IBM/DB2 the version. If you install 10.5, the same path /opt IBM DB2, it will be version 10.5 kind of thing basically. Okay, so just make a quick note of it. By default, your DB2 will be installed to this location on the Linux or Unix based servers basically. Make a quick note of it. I'll show you on my Linux servers. I'll tell you the DB2 installations tomorrow. There you can see it will ask you what is the default location where you want to install it. This is the default location. So you can see all these paths tomorrow when we are trying to cover the DB2 installations basically.
Hello, sir.
Yeah, hello?
Yeah, sir. Will you send me the material today?
Yeah, I'll send you the material.
Yeah, sir. And it is including with the Linux also, sir?
Which one? Which?
Material including with Linux, sir?
Yeah,
Linux,
I'll send you the Linux material but today try to go through this link. This link you have to understand it before. Okay. I'll forward you the Linux material also. Okay. But try to read this material. I'll explain this in much more detail way tomorrow also. Okay.
Okay.
I'll give you the Linux material also along with DB2. Okay.
Yeah, please, sir.
Yeah, sure. I'll do. Do one thing. Just you can put me email so that I can create a group for all the people. So this is my ID.
Okay.
Just drop me a test mail. So I'll create a group for all you people and I'll send you the material. Because instead of sending to each and every person, I'll create a group and send it to the group so that all the people can receive it. Okay.
Sure, sir.
Yeah. Just drop me a test mail. Okay. I'll create a group today sometime when I'm free today, and I'll keep on putting the materials together. Okay.
Yeah. Thank you.
Yeah. Yeah. So as I'm telling you, so let's say I'm installing DB2 10.5. So what is my path? Just look at this diagram and you can tell me the path now. It's on yourself basically. So if you're installing 10.5 on any Linux server, the path will be /opt/IBM/DB2/V10.5. Or if you're installing 10.1, the path will be /opt/IBM DB2V10.1. So these are the default locations where the DB2 softwares will be installed by default. Okay. So if you will see these paths in much more detail in the tomorrow's class where I will tell you the installation path. Okay. But before stopping it, I'll tell you one more command. Okay. There is one more command in DB2 which is called DB2 Ls. Okay. So I'm running this command. So what exactly this command is going to tell me? Okay, just make a note of it. In interviews also somewhere they'll ask you basically. So DB2 ls command will tell us how many copies of DB2 stored on the system. See, simple thing, let's say I have a Linux server where DB2 9.7 was installed and 10.1 was installed. I want to find out how many copies of how many times DB2 was installed. So we have to run a command called DB2 ls. If you remember, ls is a command of Linux which will tell you that how many files are there and how many directories are there. On the same lines, IBM people has written a script for DB2 ls which will tell like how many copies of DB2 software was installed. Okay. So in my server, when I ran DB2 Ls, you can see that what is the path where the DB2 was installed. OPT IBM DB2 v9.7. What version of DB2 was installed? 9.7. What is the fix pack? 4. At what date it was installed? You can see the date. Okay, so it will give you very important information. In my company, in one of the server, I have installed 9.7, 10.1, and 10.5 basically. Okay, if someone else wants to see like how many copies of DB2 software is installed and on what dates it was installed, kind of thing, they can simply run a command which is called DB2 Ls, which will tell you how many copies of DB2 is installed basically. Okay, so this is important. So just make a note of this command. So which will help you in future to find out like how many copies were installed basically. So these things will help you. Let's say 9.7 was installed on the server. In future, the people wanted to upgrade to 10.5, they upgraded it. So 9.7 was also there on the server and 10.1 was also there on the server. And the guy who worked on this project, he left the company and you joined the company to work on some things. You don't know like what version of DB2 was installed. If you want to find out like how many copies of DB2 were installed, which locations they are installed. So if you want to get those details without speaking with anyone, these commands will really help you in the future basically. Okay. Clear to this point? Any questions before I think we'll stop it for today? I think it's almost end of time for my time basically. Okay, so tomorrow the first thing which I'll do is I'll tell you how to install DB2 on Linux. But before that, try to understand this tree structure, which is important for people who don't know Linux. It's very simple thing. The first class, right? You might be a bit confusing kind of thing, but it's very simple. Slash is nothing but it's a root file system. Can I have the link for DB2 access? See, I told you, right? You can download it from Information Center. Simply go to Google. I will show you again. Go to Google and you can simply say, okay, just do Information Center for the thing which you want to go and look. I downloaded it from the same place where I'm teaching you, so you can also go there basically. So this is a place. You can search for DB2 architecture here. And you can download it from this point basically, which will be helpful for you. Okay, yeah. So this is important. The slash, the home means the user IDs will be present. All the DB2 installations will go to OPT. So these are the hierarchy which you should be knowing basically in Linux. Okay, and I'll run the commands tomorrow also. I'll show you how to install DB2 on Linux, so that it will be very, very clear for you. Then we'll see what is instance, what are the configuration parameters, how to fine tune the configuration parameters. We'll see those things in the next classes basically. Okay. Any questions before we stop it for today?
Sir, architecture, that should be fine.
Architecture, there are a lot of other things I'll be covering you. So architecture cannot be completed in 1 or 2 days. Okay, so we'll see more about the architecture also. Okay.
Okay, sure.
Okay, good. Yeah. So just drop me a test mail for today. I'll create a group for you. Okay, I'll keep on sending you the material. Okay, I'll start with sending Linux material first, followed by the architecture material and other material. Okay. Clear? Okay, so if you have anything, just drop me a mail. Okay, we'll stop it for today, then we'll meet again tomorrow at the same time. Okay, yeah.